Right. Welcome back to the third lecture of force and laws of motion. So in the last lecture we discussed about the momentum, right? Now we're going to discuss about the Newton's second law of motion and the very famous mathematical formulation F is equal to ma. Now honestly F is equal to ma, this is the incomplete formula. If we talk about, this is completely this is not the complete information. F external is equal to mass into acceleration. This is the most famous formula that is important for Newton's second law of motion or the force and laws of motion, right? But somehow the better way to write this formula is basically delta P by delta T. So nobody says that force is equal to mass into acceleration. If we go according to the physics, it says that it is the rate of change of momentum, right? It is the rate of change of momentum. So basically, how momentum is changing and how it is related to the force, this is what we're going to discuss in the Newton's second law of motion and the mathematical formulation, okay? So coming to the first example, right? So here you can see a cyclist applies force, right? And requires 2 minutes to reach from 0 meter per second to 50 meter per second. So initially he was at rest, right? Initial velocity was 0, okay? And at point B, its velocity came out to be 50 meter per second. So now you will realize that how this velocity of the particle or the cyclist change, because he applied force. That means by applying force we are getting to know one thing, that the velocity is changing. But if we talk about momentum, it is mass into velocity. So if I tell you about the initial momentum here, so initial momentum is 0, right? Initial momentum here is 0. And if we talk about the final momentum, it is, suppose, let's take the mass of an object here be m. So it is 50 m, right? And here it was 0 m, right? Why 0 m? Because the velocity of the object or the cyclist is 0, right? So now again, let's take another example. We have a boy who is riding a car, right? Driving a car. So at point B, right, it requires more force. Why? Because the mass is more. If I talk about the same velocity, right? Cyclist also need 50 meter per second. Car also need 50 meter per second. But there is a major difference. If suppose the cyclist has a mass m, for the car we have mass at least 20 m, right? So to attain same type of velocity, the car would be requiring much more force as compared to the force required by the cyclist, correct? The only thing which is same here is the velocity, but anyways mass is different, right? So higher the force, faster will be the change in velocity, right? So more force is applied, more velocity will change quickly, right? So more velocity will change quickly means more momentum change. So more velocity, more momentum, considering the mass of an object to be constant. Mass of an object to be constant. Okay, this is the thing. Okay, so what does Newton's second law of motion says? It simply states that, right, the rate of change of momentum is basically delta P is change in momentum. Remember this thing, delta P is change in momentum. Rate of change of momentum, delta P by delta T. Now what is delta P here? Mass is constant, right? So mass times V final minus V initial upon T final minus T initial. So this is the rate of change of momentum that we were talking about. Mass into final velocity minus mass into initial velocity, mass taken common. So this is change in velocity. Change in velocity into mass is change in momentum upon delta T. So T final minus T initial. Got my point? So this is the rate of change of momentum. Now it simply says that rate of change of momentum is directly proportional to the unbalanced force. Yes, obviously if there might be the balanced force, then the net force will be 0. So I can simply write it down that force is directly proportional to delta P by delta T. Force is directly proportional to delta P by delta T, and this force should be unbalanced or net force should be greater than 0. Then only this is possible. If the net force acting on the body is 0, or if I say that there is the balance force acting on the body, then it is not possible to change the momentum. Momentum will only change when there is unbalanced force on the body. Remember that. Unbalanced force means the value or the magnitude of the force should be greater than 0. Right? It should not be equal to 0. This we have already discussed. If you remember that we used to take an object, from one side this was some force, the other side this was some force, F1, F2, and F1 if equal to F2, then the net force is 0. So this is not we are talking about. It simply say, and this is the law of motion. Whenever we say the law cannot be changed, right? Okay. So second law of motion states that the rate of change of momentum, again rate of change of momentum, change in momentum is what? Delta P, that is mass into final velocity minus mass into initial velocity. But here we are not talking about the change in momentum, here we are talking about the rate of change of momentum. So rate of change of momentum is basically how much momentum is changing in a particular time interval. So that means rate of change of momentum is related to the change in momentum and with respect to taken in time. Okay, so this is the thing. So this is very different. You cannot say that it is change in momentum. It is obviously rate of change of momentum. Okay, got my point? So now we have this example. The mass of the car is taken m here, right? Here the initial velocity is u, and at some point we apply some force, right? That force can be applied due to the engine only. That mechanical force can be applied by the engine. There is no need that we are externally applying the force. The external force can be applied by the engine as well. Okay. So in time t, like suppose the force was acting, then in time t, the velocity at point B became v meter per second. So this is the initial velocity at A, this is the final velocity at B. So this is changing because for a particular time interval there was force acting. Okay, then we can simply say that okay, initial velocity was u, final velocity was v. So P1 here, P1 is mu, right? P1 is mu, P2 is simply mv, right? So when we do P2 minus P1, P1 was the initial momentum, P2 was the final momentum. So now we need change in momentum. So what is change in momentum? P2 minus P1, right? What is rate of change of momentum? P2 minus P1 with respect to time. Okay. So change in momentum upon time. Okay. Change in momentum upon time. This is rate of change of momentum. So how we can write this? mv minus mu by t. mv minus mu by t, which we have already discussed. Mass again v minus u by t, and v minus u by t is basically acceleration, right? So v minus u by t is basically acceleration, then force is equal to mass into acceleration. This is the final formula, okay? So rate of change of momentum is basically equal to ma. This is what you have to remember, or you can also write down like this. This is more significantly in physics, delta P by delta T is equal to ma, because delta P by delta T is the net force and ma is also the related to net force. So delta P by delta T is equal to ma. In NCERT, when we write force is equal to directly proportional to delta P by delta T, okay, so we remove this proportionality constant and we put equal to, right? So when this proportionality sign is removed, we need a proportionality constant, we put k, so it becomes force is equal to kma, but eventually this proportionality constant has value 1. So finally this is how we get F is equal to ma, but this is not the exact formula. This is the real formula, but this is the most usable formula, okay? This has the significance that relates net external force with the acceleration. Yes, this is the Newton's second law of motion, but I would suggest that you try to remember this formula, because this formula will help you in class 11th as well. Okay, got my point? So this is how F is equal to ma came out to be, and sometimes in some school level exams, they'll ask you that what is the value of k, so you can simply say that k has value 1. Okay, got my point? Let's come to the next part. So rate of change of momentum is directly proportional to the applied force. This is what we have already discussed, right? F is equal to kma. If k is equal to 1, then F is equal to ma. Okay. Force, unit of force, distinguish between force and momentum. Now, when we talk about force, obviously it is named after a very famous scientist. So the unit of force is again Newton, and this is the sign, right? N. So if I want to write down the unit for force, I can simply say that okay, 5 Newton force is acting, or 10 Newton force is acting, or 20 Newton force is acting. So Newton is basically the unit of force, right? It is SI unit of force. So one is the SI unit, one is the MKS unit, one is the CGS unit. So MKS unit is basically the SI unit here, right? Also, 1 Newton is equal to 10 to the power 5 dyne. So normally it is dyne basically. 1 Newton is equal to 10 to the power 5 dyne, right? And dyne is the CGS unit, okay? CGS means centimeter, gram, second, and Newton is the SI unit, which is applicable everywhere, okay? So when we talk about the force and when we discuss about the force and momentum, at least we should be clear with the units, right? So unit of force is again Newton, or I can say 1 Newton is equal to when 1 kilogram object moves with the acceleration of 1 meter per second square, right? So 1 Newton is equal to 1 kilogram object when moving with an acceleration of 1 meter per second square. Then we can say that it is moving because of 1 Newton force. This is what we need to remember. So what is 1 Newton? Again, write down this. 1 Newton is basically when 1 kilogram object moves with the acceleration of 1 meter per second square. That is when we term it as 1 Newton, because they will ask you what is unit force. So you can simply tell about the unit force, okay? Coming to momentum, this we have already discussed. It is denoted by P, it is mass into velocity, unit of mass is kilogram, velocity unit is meter per second. So when we say that if anybody has 1 momentum, that means 1 kilogram object is moving with a velocity of 1 meter per second. Okay, so there is a big difference. Momentum is related to mass and velocity, force is related to mass into acceleration. Got my point? So don't get confused at all. If we have to simply distinguish between force and momentum, you can check with the velocity and acceleration. For force, it is 1 kilogram meter per second square, and for momentum, it is 1 kilogram meter per second. So there is a very major difference, right? It is not just that, okay, 1 second is extra here, right? There for second we have power 1, and for second there we have power 2. No, the physical significance and velocity, obviously, of velocity and acceleration are very different. Basically, velocities, if you talk about the velocity in simple word, it is basically related to the speed. But acceleration is related to change in velocity, right? How much velocity is changing in some time interval. So there is a big difference. So you can easily distinguish that, okay, one is force and other is the momentum. So you get the unit of force with the mass and acceleration, you get the unit of momentum with the mass and velocity. This is how we can simply understand that, okay, this is the force and this is the momentum. Okay, got my point? Now, this is the most important thing. It's a vector quantity. Now, if I want to explain it to you in a very simple word, so I can simply say that mass here is a scalar quantity, right? Mass here is a scalar quantity. Acceleration is a vector quantity. So scalar into vector, if you multiply any scalar quantity with the vector, you will simply get what? A vector quantity. That means force has magnitude as well as direction. Okay, similarly to the acceleration. Acceleration is also a vector quantity, velocity is also a vector quantity, displacement is also a vector quantity. Displacement, velocity, acceleration, force, all these physical quantities are vector quantity. Why? Because they have both magnitude and direction. And when I taught you this topic, scalar and vector quantity, I simply told you that one thing with the magnitude is the scalar, and other thing with the the magnitude and the direction is vector. So very basic approach you should keep. And for 2 chapters that those are coming in term 1, you can simply write down that, okay, displacement, velocity, acceleration, force, these all are the vector quantity. Okay, got my point? So now we have force is equal to ma. This we have already discussed, where m is the mass, a is the acceleration. So SI is equal, like SI and MK as unit are taken same, and one is the CGS, right? So kilogram meter per second square, and there is gram centimeter per second square. In SI we write Newton, in CGS we write dyne. Okay, so Newton is the SI unit, okay, and dyne is the CGS unit. I also told you the relation, 1 Newton is equal to 10 to the power 5 dyne, because here 1 Newton will convert into 1 kilogram meter per second square, right? And if we want to convert kilogram in meter, so it is 1 into 1000 gram. Okay, and meter is 100 centimeter. So 320 10 to the power 5, so it will become 10 to the power 5 gram centimeter per second square, and gram centimeter per second square is the dyne. Got my point? This is how the relation is. So remember, SI unit or MKS unit is the Newton, which is related to kilogram meter per second square. For CGS, it is dyne, which is related to centimeter gram per second square. Okay, so I hope till here it is clear, right? So now let us define 1 Newton and 1 dyne, right? So we have already discussed this. What is 1 Newton and 1 dyne, right? So basically 1 Newton is the SI unit, and we also discussed that, okay, it is SI unit or MKS and this is CGS, right? So 1 Newton and 1 dyne is basically when we'll put F is equal to MA, so in the place of force, it's 1 Newton, right? So 1 kilogram object when have acceleration 1 meter per second square, then we can simply say that, okay, it's 1 Newton. Similarly, this is the definition that many school asks. The force necessary to accelerate an object with 1 meter per second square and the mass of the object should be 1 kg. So this is the necessary definition that, you know, in school level they can ask, right? The force necessary to cause an acceleration of 1 meter per second square in an object of mass 1 kg. Okay, so that is 1 Newton basically. And when we talk about 1 dyne, so it is 1 gram per centimeter square. So what is 1 dyne here? The force necessary to cause an acceleration of 1 centimeter square in the object of mass 1 gram is called 1 dyne. Okay, so let's solve this question. A truck of mass m is moved under a force F. So mass m, force F. Okay, if the truck is then loaded with an object equal to the mass of the truck and the driving force is halved. So if I found out the acceleration here, so F is equal to ma, right? So A is basically F by m. Now I want to check how much acceleration will change. Force is becoming half, so it is becoming F by 2, right? So new acceleration A dash is basically F by 2, right? And mass is also doubled, so it will become 2 into 2m, that is 4m. So F by 4m, right? And F by m is basically the acceleration. So A dash will become A by 4. Okay, that means 1 by 4 of the old acceleration, right? 1 by 4. Got my point? So this is how, you know, we can tell that force is dependent on both mass and acceleration. If you change the mass, force will change. If you change the acceleration, force will change. Okay. Now we have already discussed this distinguish between force and momentum. So it's a physical quantity that changes or tend to change the state of rest or uniform motion of a body in a straight line. So basically force is a physical quantity which tries to change the state of an object. Okay. Momentum, if we talk about momentum, it is a product of mass and velocity. Simply, there is no other particular definition for momentum. Okay. The unit of force is Newton in MK system and dyne in the CGS, whereas obviously it is kilogram meter per second and gram centimeter per second, because this is already we discussed. I told you that for force it is mass into acceleration, and for velocity it is, for the momentum it is mass into velocity. So there, one in force we have the acceleration, but in the momentum we have the velocity. Okay. Now this is the formula for both of it. Force is equal to mass into acceleration and momentum is mass into velocity. Also we have the relation F is equal to delta P by delta T. This is the most important thing that we need to learn to solve all the type of numericals. Okay. Now coming to the last law of the motion, that is Newton's third law of motion. So Newton's third law of motion is very incredibly famous. It simply states that every action has an equal and opposite reaction, right? So every action has an equal and opposite reaction. So this is Newton's third law of motion, and there is so much to understand in this Newton's third law, but just remember that Newton's third law simply states that every action has an equal and opposite reaction. So the reaction will be opposite and equal. Okay. So for every action there is equal and opposite reaction. Let us now study the Newton's third law of motion. So again, the Newton's third law of motion states that every action force has an equal and opposite reaction force. Now we'll discuss this statement, this law with the examples, and then we'll realize that okay, this is how the things are, right? The fuel of the gas of rocket exerts a downward force and on the surface of the earth, due to which, see, a very basic example, right? There is one term called thrust. Thrust is basically the perpendicular force that we talk about. Okay? Right? So because these gases are coming out like this, right? Due to which they are exerting thrust on the earth. Now more will be the thrust, more will be the force, more will be the reaction. Now this is the reaction, right, in the air or maybe to some surface. If this is the reaction by the rocket, what will be the reaction? Reaction will be just the opposite, right? So rocket is able to move upward, or it can move this way because of the reaction force exerted by either the surface or the air particles, right? So we normally say that more will be the thrust, more will be, the acceleration of this rocket. Thrust is more, the acceleration is more. Right? Because more action or the more force exerted by the rocket on the surface of the earth, more will be the reaction and hence more will be the acceleration. Okay, so this is the very first basic example that describes action and reaction force. That describes action reaction force, right? Okay, let us consider this example when the boy is jumping on the trampoline, right? When he is jumping, he is applying a downward force. If you take a close look, he is applying a downward force. Downward force on the trampoline, right? But trampoline is exerting an upward force, right? So again, just take a look at this. See, right? This is what it is happening here. Every time we talk about action, so action is exerted by the boy on the trampoline, and the direction is downward. Downward force. Okay. So boy on the trampoline is exerting a downward force. This is considered to be action. Okay. Trampoline exerting an upward force by trampoline on the boy. So you need to remember that this action and reaction are acting on two different body. Action is being exerted on the trampoline. Okay? Action is being exerted on the trampoline. So I'll write down this here. Action on the trampoline. But reaction is on the boy. So action is on the trampoline, reaction is on the boy. That means these two forces cannot cancel out each other. So there is a statement in the NCERT that action-reaction pair does not cancel out each other. So they ask the question normally that why do not they cancel out each other? Because it's a very simple answer here. You can see with the example as well that for every action there is an equal and opposite reaction. But if action force is acting on one body, then reaction force is acting on the other body. So one body is facing action and other body is facing reaction. So they cannot cancel because there are two different bodies. So action reaction pair cannot cancel out each other because of the one reason that we talk about is that they are acting on two different bodies. This is what you need to remember. Okay? Action reaction pair, what is action? It is acting from one body to another body, body 1 to body 2, and reaction is body 2 to body 1. So they will not cancel each other at any situation, any. So any example we take, horse is pulling the cart, horse is exerting force on the ground, ground is exerting force on the horse. They cannot cancel out each other. The force exerted by the horse on the cart, on the ground is action. Force exerted by the ground on the horse or the cart is the reaction. So one force is experienced by the horse and other force is experienced by the ground. So when there are two different forces which are different experienced by the two different objects, they cannot cancel out each other. So there is a very important statement in Newton's third law of motion that action reaction pair do not cancel out each other, and this is what you need to remember. Okay, this is what you need to remember. For every action there is an equal or opposite reaction. This is perfectly fine, but they will never cancel out each other. Okay, got my point? Right, coming to the next part. So this law speaks about the interaction between the two bodies, right? Like we discussed for the rocket, and earth, right? Boy and trampoline, right? Horse and ground. So this law basically talks about these two bodies are interacting with each other. No, rocket is interacting with the earth surface, boy is interacting with the trampoline, and horse is interacting with the ground. Right? Interaction means the interaction here means the force. Interaction here means the force. And remember, these forces, and this is the most important point, these forces act in pairs. Now for every action, this is what Newton told us, that for every action there will be reaction, right? So it is always acting in pairs. Pairs means action, reaction, reaction, action, right? This is what pairs are. And they cannot exist by itself. That means without the action you cannot have the reaction. Without the reaction you cannot have the action, right? Or without the, if there is some action, there needs to be some reaction, right? It cannot happen like there is only action and no reaction. Or it cannot happen like there is no reaction, just the action. So it get both ways, right? For every action, there needs to be reaction. So they always exist in pair. Okay, they always exist in pair. Got my point? So action, reaction, force acts simultaneously. So they are always acting simultaneously. Like if there is action, there would be reaction. Okay. At the same time, there is no delay, no time lag. But when we talk about the force, they are equal and opposite, and yes, they cannot cancel out each other because they are acting on two different bodies, right? Okay. So basically the revision of three rules, because all the three rules are done, right? So the first one was the talking about. Okay. So Newton's first law of motion, when you talk about, gives an idea for the inertia, right? So first law of motion is for the law of inertia. Newton's second law gives the idea for the effect of forces. Newton's third law describes the relation between the forces and the two interacting object. Okay, let's take the example here. In a high jump athletic event, the athlete are made to fall on a sand bed. Second is motion of a rocket. Only the carom coin, right? So this goes for the first law of motion, the carom coin, because it is because of the law of inertia, right? Newton's second law of motion, in high jump athletic event, the athletes are made to fall on the sand bed. And Newton's third law of motion, obviously motion of a rocket, because we just discussed it yet. Okay, so these are the three rules and three examples that we discussed. Okay. Now, let's talk about some more questions. Since the action and reaction forces are equal in magnitude and opposite in direction, how can anything ever be accelerated? Now, this is a very good question. We can say in simple words that action is acting on one body and reaction is acting on the other body. So because of the action, there is some net force on the one body, and because of reaction, there is some net force on the other body, right? Because they act on two different bodies, so they cannot cancel out each other's. Hence, the net force on the body is not zero. If net force on the body is not zero, net force non-zero, not equal to zero, so it is unbalanced, right? So obviously, but even then they do not cancel out each other, so it's a very basic answer that you can simply write down in one word, that they act on two different bodies at the same time, right? If action is acting on A body, then reaction will be acting on body B. Okay, this is because action and reaction act on different body. This is just the one line answer. Okay, a man is at rest in the middle of the pond on perfectly frictionless ice. How can he get himself to the shore, right? So he has to apply some force, right? Yes or no? Okay. So if the answer here is if the man throws away his shirt in a direction opposite to the desired direction of motion, he can get himself to the shore. I'll explain this how. See, like suppose this is the thing, okay, and he want to get this side, like suppose this way. Okay, so if I apply force here, the reaction will be here. Yes or no? Just the opposite side, no? Getting my point? If I apply the force here, so this will be the action, but reaction that the man will get will be on the left hand side towards the shore. Yes or no? So in simple words, we can say that if I want to if I want to move towards shore, I'll start exerting force on the opposite side of the shore, right? I'm applying the action here, but the reaction I'm getting towards the shore, so hence I'll move in this direction. Okay, got my point? Let's move to the next question. Now, Law of conservation of momentum. We'll talk about this in a very elaborative manner. Law of conservation of momentum. This conservation of momentum is only possible if the net external force is zero. If there is some net external force, then the law of conservation of momentum is not applicable. So net external force needs to be zero, then only you can say that okay, we can apply conservation of momentum. Now what is conservation of momentum here? We have to understand, like if I write a simple statement, m1u1 plus m2u2 is equal to m1v1 plus m2v2. m1u1 plus m2u2 is equal to m1v1 plus m2v2. Now what are m1 and m2? Obviously these are two objects with different masses. What is u1, u2? Initial velocities. What are v1 and v2? Final velocities. Now, how this conservation of momentum works, we'll discuss on that. But this is what you need to remember. m1u1 plus m2u2 is equal to m1v1 plus m2v2. Okay? Where m1u1 is the initial momentum, of first body, initial momentum of second body, final momentum of first body, final momentum of second body. Right? So this is what we're gonna discuss further. Okay? So this is the example for law of conservation of momentum. Just take a look. So there is a truck and a car, right? So when two objects collide, the total momentum before the collision and post collision will be same, because the net external force is zero. Now this is very important point, that conservation of momentum, again I am saying this to you, that conservation of momentum is only applicable when the net external force is zero. Because we have, like this in class 9th, it's very soon to say, but listen to me very carefully. If I take this truck and car as a system, you know, now this truck and the car is a part of the system now. So before collision, now listen to me very carefully, this is very, very important. Why here this conservation of momentum is applicable? Because of the system consideration. If we are taking a system of truck and a car, then net external force on the system is zero. Next external force on the system is zero. If the next external force on the system is zero, then only you can apply conservation of momentum. Now I can take any system I want. I can take truck and earth be the system, car and earth be the system, truck and car be the system. So that completely depends on me. But if I take truck and car to be the system, the force exerted by car on the truck and the force exerted by truck on the car will become the part of the internal forces, because now this force is acting in between the system. No, that's why. So they will consider to be as internal forces. And I have told you plenty of times that we will only consider when the net external force is zero. So when force exerted by the car on the truck and truck on the car, when the force exerted between these two becomes a part of the system, then they are not the external force. They becomes the part of the internal force, and hence we can apply the conservation of momentum. Okay, now I know in class 9 this is not very easy to understand that what kind of a system do we take, but any type of question that you are getting, a horse and ground, bullet and gun, truck and car, so they are all in the same system. This is what you can learn for right now, and when you will go to class 11 then you will realize that okay, what exactly sir was saying about the system. Okay, because certain things it comes with the the more time, it comes with more time, and it comes with the idea when you level up little bit, level by level you go, like in the higher studies you will realize that okay, and then also with the age you will have better understanding. So for now, obviously when it comes to physics, I tried to teach the best thing, but this was important to tell you because in none of the books for class 9th or even in the NCERT it is not given that why the net external force is 0, and somewhere even this point is not included. We are only just saying that okay, car is exerting the force on truck and truck is exerting the force on car. That's it, this is what we are saying, and then we are just doing the law of conservation of momentum, and nobody is talking about why the law of conservation of momentum is applicable. So it was very important for me to tell that law of conservation of momentum is only applicable when the net external force is 0. This is very, very, very important. Okay, so when we'll take system of a car and a truck, the force exerted by truck on the car and car on the truck will become the part of the internal forces, and hence we can make this law applicable because now there is no external force, it is just the internal force. So take a look here, right? So eventually what happened, this truck and the car collided, right? So even after the collision, what happened, this truck didn't went away, the car went away. Just take a look here. This is very important. This is very important to understand that what happens before the collision and what happens actually after the collision, right? This car and this truck is moving with the velocity u1 and u2 respectively. Okay, so they collided. Now how they collided? The truck was moving towards the car and car was moving towards the truck, right? In the video there might be a possibility that you can clearly see that truck is approaching, but we still say post collision, because truck is kind of a heavy, right? So car will move back. Take a look, car will move back after the collision, right? Or we can say before collision the distance, like it was the approaching velocity. We had velocity of approach. They were approaching each other, right? Post collision they are separating, right? So before collision it is velocity of approach, and post collision it is velocity of separation. This is what you can remember, because this is very basic thing. Like if two bodies wants to collide, they need to approach each other, right? So velocity of approach and velocity of separation. Got my point? So F1 is the force exerted by car on the truck. F2 is the force exerted by the truck on the car. So F2 is on the car, F1 is on the truck. Okay, so every action has an equal and opposite reaction, and these two are equal and opposite. So this is action reaction pair. Again I'll say this to you, action reaction pair will never cancel out each other, because one force is acting on the truck and the other force is acting on the car. So one force which is acting on the truck is F1 and the other force which is acting on the truck, in the car is F2. Okay, so on the truck it's F1 and on the car it's F2. So consider F2 be the action, then F1 will be the reaction. If you consider F1 to be action, F2 will be the reaction. So either way, it goes both ways. Okay, so you need not to worry. So F1 will be equal to minus F2. This is what you need to remember. F1 will be equal to minus F2. Why? For in every action there is an equal and opposite reaction. So F1 is the action. Opposite, for opposite we make minus. Okay. So F1 will be equal to minus F2, or we can also write this like F1 plus F2 is equal to 0. See, again net external force is 0, right? So let's deduce this formula. Okay. So deduce the law of conservation of momentum by Newton's third law. This comes under, like in 5 marks question, I have really seen many a times that it comes to derive. So it is the derivation, it is very important that you derive it. Okay. This diagram I have taken from the NCERT because it has to be done the same way it is given in the NCERT. So just think that I have object A whose mass is ma, other object B whose mass is mb, moving with velocity ua, okay, moving with velocity ub. So ua and ub are the initial velocities of A and B, where it is very important that ua will be greater than ub. Okay, then only it will able to approach this. No, otherwise this won't approach. A body won't approach the B one, right? So ua has to be greater than ub. Okay, then FAB. What is FAB? FAB is the force exerted by body A on body B. Okay, got it? So FAB, force on B due to A. Okay, FAB is the force exerted by A, force by A on B. Okay, so FAB is in this direction. What about force BA? Force on A or by B on A. Okay. This is what you have to remember. What is F12? Force on 1 to 2. What is F21? Force on 2 to 1. Right? This is what you have to remember. Okay. So FAB is equal to minus FBA. Why? Again the same thing. FAB considered as action, then F minus BA is the reaction. Okay, so FAB and minus FBA. So post collision this will move with VA and VB. So let's talk about force exerted by A on B is force AB, right? So force AB is rate of change of momentum of A, right? So force exerted by B on A is rate of change of momentum of B. So FBA and FAB. So rate of change of momentum is MA times VA minus UA by T. B is MB times VB minus UB by T. If we apply Newton's third law of motion, for an action there is an equal and opposite reaction. So FAB is equal to minus FBA. For FAB, write down MA times VA minus UA by T is equal to minus of MB VB minus UB by T. Now this T will be cancelled, right? When you multiply this, it will become MAVA minus MAUA is equal to MBVB minus MBUB, right? So when you will write down this, so this will be the result, right? Finally, MAUA plus MBUB is equal to MBVB plus MAVA. So total momentum before collision will be equal to the total momentum after the collision when net external force is 0. Okay. So total momentum of the two bodies is conserved when no external force acts on them. This proves the law of conservation of momentum. This is the law of conservation of momentum, and this comes generally in 3 or 5 marks, and it is very, very important, but it is very basic. If you just go through the basic, you will be able to understand it. Okay. So that's all for today. We'll continue with the questions and certain topics which are left in the next lecture. Till then, bye bye, enjoy, thank you.